Let's first of all have a recap of some key points. First key point, we have that the equation of the straight line is y equals ms plus c. Now the point P lies on this straight line, so we can substitute the point P into the equation of the straight line. In place of y, substitute the y coordinate y1. In place of s, substitute the s coordinate s1. When a point lies on a function, we substitute that point into the function to solve. Now, second key point, we have a straight line that passes through the point C. This straight line is a horizontal line, a line that is parallel to the x-axis. What is its equation? Its equation is going to be y equals c. This horizontal line passes through the y-axis as c, so its equation is going to be y equals c. Y equals c. Now let's have a vertical line that passes through the x-axis at w. What is going to be the equation of this vertical line that passes through the x-axis at w? This equation is going to be s equals w. The vertical line passes through the x-axis at w, so this equation s equals w. Now, let's solve the question. Solutions by accurate drawing will not be accepted. The line y equals ms plus 4 meets the lines s equals 2. What is the line s equals 2? The vertical line that passes through the x-axis has 2, so this is the line s equals 2. And s equals minus 1. The vertical line that passes through the x-axis has minus 1. So the line here s equals minus 1. Equation says that the line y equals ms plus 4 meets these two lines at the point P and Q respectively. So we see P here 2, 10, and then Q. What's the coordinate of Q? Coordinate of Q is going to be minus 1, a certain y value that I don't know. This very minus 1 here, the coordinates of Q is going to be minus 1, w. Minus 1, a certain y value you don't know. Now, okay, let me name it y1. Minus 1, y1. The point R is such that QR is parallel to the y-axis. QR. So let me put an arrow on QR and then a y-axis. Equation says that these two lines are parallel. The gradient of RP is 1. This line RP, gradient of RP is giving us 1. The point P has coordinates 2, 10. Okay. Now find the value of M. Finding the value of M, the M over here in the equation of the line QP. We see that the point P 2, 10 lies on the line y equals ms plus 4. So we can substitute the point P into this equation to solve. The y value is 10 because m, the s value is 2. So we get 2m equals 6 dividing both sides by 2, the value of m is 3. That's the first question. The next question says that find the y coordinate of q. Again, we see that, okay, from question number I, the general equation y equals ms plus 4 is now going to be y equals 3s plus 4. Now the value of y, the value of m is 3, so substitute 3 for m, you get this. Now, for question II, we have to solve for the y coordinate of q. This coordinate q minus 1, y1 lies on the line y equals 3s plus 4. So we substitute coordinate of q into this. The y is y1 equals 3 multiply the x values minus 1 plus 4, and that gives minus 3 plus 4 gives you 1. So the y coordinates, the answer to question II is positive 1. Tells us coordinate of q minus 1, 1. Next question. We have solved question I. Next question says find the coordinate of r. Finding the coordinates of r, we see that we are given a gradient of rp. Okay. Gradient of rp should be equal to, now coordinate of r is not directly given, we can write it coordinate of, since we have minus 1 here on the exercise, coordinate of r is going to be minus 1, a certain y value y2 that we don't know. So gradient of rp should be equal to change in y2 minus y1 divide change in s2 minus s1. Now, in the equation we are giving gradient of rp as 1. Gradient of rp is given as 1. So we write 1 equals y2 minus 10 divided by minus 3. Multiplying both sides by minus 3 to clear the fraction, you get minus 3 equals y2 minus 10, which in 10 gives. So the value of y2 is 7. That's to say that the coordinate of r, it tells us that coordinates of r is going to be minus 1, 7. The next question IV asks that we find the equation of the line through P perpendicular to PQ. So maybe we should make a sketch of that. A line that passes through P and at 90 degrees to PQ. And we have the 90 degrees over here. Okay, since these two lines meet at 90 degrees, we use the gradient of PQ to find a gradient of this line we are drawn through P. Now, what is the gradient of the line PQ? Gradient of PQ is right here in the formula, in the equation of the line PQ, y equals ms plus 4. We had a value of m as 3. Gradient of PQ is 3. So it tells us that gradient of this line that passes through P, maybe let me name it PT. Gradient of PT is going to be minus 1 divided by gradient of PQ. So equation of this line that passes through P is going to be y minus y1. Now the coordinate P 2, 10 lies on the line we are finding, so we can substitute these values s equals 2 and y equals 10 into the general equation of straight line. Y minus y1 equals gradient multiply s minus s1. So we get y equals 1/3 s minus 2 out of 3 plus 10, and this gives y equals 1/3 s plus 28 out of 3. Now we have to write our answer, leave our answer in the form as plus by equals c. So clear the fraction by multiplying 10 by 3, 3y equals s plus 28, 3y minus s equals 28. We have gotten our answer in the required form. Now, question V says find the midpoints, find a coordinate of the midpoints M of the line PQ. The coordinate of P, the coordinate of Q is minus 1, comma 1. In previous working, we had the value of y1 as 1. And now the coordinate of Q in a diagram. Coordinate of P in a diagram is 2, 10. So I write 2, 10 here. Now question says we should find the coordinate of the midpoints M. What's the formula? Midpoints equals sum of the s coordinates 2 plus minus 1 divided by 2, comma sum of the y coordinate 10 plus 1 divided by 2, and that gives the midpoint as 1 out of 2, comma 11 out of 2, which you can write as 0.5, 5.5, 0.5, 5.5. Now the next question, VI, says that find the area of triangle QRM. So the point here is P. Triangle QRM. We got midpoint of PQ as 0.5, 5.5. Now we have to find the area of the triangle QRM. So we use the shoelace method. Half multiply absolute of, when you go to point coordinate Q, the s value there is minus 1. Coordinate R, s value there is minus 1. Coordinate M, the s value is 0.5. Come back to coordinate Q, s value there is minus 1. Now, for the y values, coordinate Q, s y value is 1. Coordinate R, y value is 7. Coordinate M, y value is 5.5. Come back to coordinate Q, y value is 1. So now we take the sum of the downward products. Minus 1 multiplied 7 gives you minus 7. Minus 1 multiplied 5.5 gives you minus 5.5. 0.5 multiplied 1 gives you plus 0.5. Minus, now this all you do, you take the sum of the upward products and separate from the first bracket. So 1 by minus 1 gives you minus 1. 7 multiply 0.5 gives you 3.5. This one gives you minus 5.5. The first bracket gives minus 12. Now minus, the second bracket gives minus 3. So that gives half multiply absolute of minus 12 plus 3 gives you minus 9. Absolute of minus 9 is positive 9. Half multiply 9 gives you 4.5. So the area of triangle QRM is 5.5 square units.